Welcome to The Explainer. In this one, we're going to get our hands dirty and really dissect the anatomy of a modern, high-performance .NET backend, looking at everything from a single line of code all the way up to the cloud. So what's the secret sauce? I mean, what really separates a backend that just works from one that is truly elite? It's not just about getting the job done. It's about engineering quality into every single level, from the code itself to the globally deployed system. All right, so let's jump right in. We're going to peel back the layers and look at the 4 critical areas that really define what a top-tier backend service is made of. Okay, first things first, you have to start at the very bottom, right? The foundation. And that's the code itself. You can think of it as the nervous system for your entire service. If this isn't solid, nothing else matters. Now, these 5 solid principles, they're not just some academic buzzwords you learn and forget. They are the absolute bedrock of code that you won't hate in 6 months. For instance, single responsibility is simple, right? A class should do one thing and do it well. Dependency inversion is just a smart way of saying your big picture strategy shouldn't get bogged down in tiny details. If you follow these, you create a foundation that can actually evolve without crumbling. And check this out, this is a perfect example of a modern C# strategy that will save you so much headache. On the left, you've got your standard mutable class. Its state can be changed from anywhere at any time, which is how you get those nightmare bugs that are impossible to trace. But on the right, an immutable record. Its state is locked in the moment it's created. This one simple switch just wipes out an entire category of nasty concurrency problems. It makes your code way more predictable. All right, so our code foundation is solid. Let's move up a level. How does our service actually talk to the rest of the world? We're talking about the API layer now, and this is where performance and, maybe even more importantly, security are absolutely critical. Okay, middleware. The thing you have to get right is that it's a pipeline. The order matters a lot. You want the cheap, fast security checks to happen first. Think about it. Why would you waste CPU cycles on a request you're just going to reject anyway? So things like CORS and authentication, you run those right at the start. Nailing this order is a huge win for both security and raw performance. This slide really gets to the heart of a major shift in how we build applications. The old way was these horizontal layers: UI, business, data. The problem was, changing one small feature meant you had to touch files in all 3 layers. It was messy. The modern approach, vertical slices, is so much smarter. You group all the code for a single feature together. This makes your system way easier to understand and, crucially, way easier to change without breaking everything else. Now for the layer that is, let's be honest, often the source of our biggest headaches. We're talking about data. This is where you find the nastiest performance bottlenecks and the trickiest bugs. It's the beating heart of the application, so we have to get it right. When you're working with data in .NET, this is one of the classic choices. On one hand, you have EF Core, a full-blown ORM that's fantastic for productivity because it translates your code to database queries for you. On the other hand, there's Dapper, a micro ORM. It's lightweight and gives you raw speed by letting you write the SQL yourself. So the decision comes down to a fundamental trade-off. Are you optimizing for developer convenience or for absolute performance? So here's a common nightmare. 2 users try to edit the same record at the exact same time. How do you stop one from overwriting the other? Well, you could lock the data, but that's slow. A much more elegant solution is something called optimistic concurrency. It's optimistic because it assumes conflicts are where. So it just does a quick check before saving, hey, has this data changed since I first read it? And here's what that looks like in EF Core. It's surprisingly simple. It's really just this little try-catch block. If EF Core detects that someone else modified the data while you were working on it, boom, it throws this very specific exception. And inside that catch block, you're in control. You can decide how to handle the conflict, tell the user, merge the changes, or just try again. Finally, we've built our service and it's been deployed. But our job isn't over, not even close. How do we make sure it stays healthy and that we actually understand what it's doing out there in the wild? This is all about monitoring the living system. Look, you can't have a reliable system if you can't see what it's doing. And observability really comes down to these 3 pillars. Logs give you the detailed event-by-event story, metrics give you the high-level numbers and trends, and traces let you follow a single request on its journey across multiple services. You absolutely need all 3 to get a complete picture of your system's health. Health checks are the vital signs of our service, especially in a world of containers. The liveness probe is simple. It just asks, are you running? If not, the orchestrator restarts it. The readiness probe is smarter. It asks, are you actually ready to do work? Maybe the app is up, but the database connection is down. If it's not ready, the orchestrator stops sending it traffic. It's a crucial difference. This timeline shows the careful dance of changing your database without taking the app offline. The golden rule is to never make a breaking change. You move in small, safe steps. First, you add the new column. Then you deploy code that writes to both the old and new. You migrate the data in the background, deploy code that reads from the new column, and only then, once you're 100% sure it's all working, do you clean up the old column. It's a disciplined process that keeps the service running the whole time.
So, what have we seen? What's the big takeaway? It's that an elite backend doesn't happen by accident. It's the result of intentional engineering. It's a commitment to quality that flows through every single layer we've discussed, connecting the smallest line of code to the largest cloud deployment. And that is the difference between a service that just works and one that's truly reliable.